Hello, everyone. How are you today? Hope everyone is off to a good Wednesday/Thursday, depending on where you are. We're going to try something a little different today. So I've been talking to people and been trying to figure out, like, how do I get some little snippets of intro to Sudoku variant stuff into the stream? And so I've sort of settled internally on a format I want to try, at least for a few streams. We'll see how it goes. So this is the format that I'm going to go with. I'm going to pick a constraint. Today, that constraint is Kropki Pairs, which I'll define for you in a second. And I'm going to do 3 gas puzzles with that constraint. So what is a gas puzzle? If you've never seen a gas puzzle before, there's one posted every day on the Cracking the Cryptic Discord. And they're meant to be quick puzzles. So they're meant for people to speed run a lot of the time. I'm not going to speed run them. I'm going to go slow and try and explain all the different steps that go through them. And then after I do the 3 gas puzzles with that constraint, I'm going to find a puzzle that is 2 or 3 stars and do that puzzle with that constraint and sort of talk about what we've learned. So I'll try and sort of teach you the things to look at when you're looking at a Kropki Pairs puzzle, and then we'll do some puzzles and so you can see it done. And then after we've done that, I expect that's going to take an hour-ish. We'll see. After we've done that, then we'll hop in and we'll do the most voted on puzzle, which I'm looking forward to because it has Renbon in it and other reasons. But we have a most voted on puzzle from the bucket, which is a directionary ambiguity puzzle that should be great. And then we'll go on and we'll sort of stream as usual. But I want to have these, and I want to have them at the beginning to sort of welcome new people. And I want to have them sort of be clippable so that people can go back and be like, okay, what is it I'm supposed to know about Kropki? And then know what they're supposed to do. Okay. So you'll see these dots, and I'm starting with Kropki because you'll see these dots sort of scattered in their own puzzles, but also in lots of other puzzles. So it's pretty common to have a puzzle that will have some variant, but then it'll have a few of these dots, a few black dots, a few white dots, or whatever. Naverio says that he believes this will take more than an hour. We'll see. Well, we've got plenty of time today, so I'm going to take however long it takes. So white dots, whenever you see them, they essentially always mean that these 2 digits are consecutive. So they mean, for example, I should turn the number pad on. It'll take a lot longer if I don't turn the number pad on, I'll tell you that much. So these could be a 6 and a 7. This could be an 8 and a 7. Well, that doesn't work. It could be an 8 and a 9, for example, and then this could be a 7 and a 6. So we've got this sort of pattern going on that's what white dots mean. Black dots mean that there is a ratio of 1 to 2 between the 2 things. So one of them is double the other. So this could be a 4 and a 2, for example, or an 8 and a 4. Or you can imagine what all the other variations are for one is double the other. And again, you don't know. It's not like there's no left to right preference. It could be 8 to 4 or 4 to 8. Either way, it does not matter. All right. Now, every puzzle we're going to be doing today is what is properly called a Kropki Pairs puzzle, as opposed to a Kropki puzzle. These are called Kropki dots frequently, although that's a bit silly because Kropki actually is the Polish word for dots. That's why they're called Kropki, if you're curious. But when someone says that there is a Kropki puzzle, what they theoretically should mean, although this is pretty uncommon these days, but what they theoretically should mean is that actually, in addition to everything I just said, there's also what's called a negative constraint, meaning that I could not put an 8 next to a 4 without a black dot between them. But that's not what's going on here. In all the puzzles today, they're just what's called a Kropki Pairs puzzle, which just means some dots are given, but not necessarily all of them. And so you'll see that that's phrased in the directions as there are no negative constraints. And so a negative constraint is when you say that actually all possible clues of a certain type are given. That's not the case here. Okay, so I've attempted to prepare a visual because I've tried to sort of draw this picture in the air lots of times. First of all, I'll say black dots are better than white dots in terms of information they're given. And so this little picture you can have in your head of how black dots are related. So this has every digit 1 through 9, and every digit or every possible black dot relationship is given. And an awful lot of the deductions that we're going to show just follow from looking at this picture. And so I want to point out a couple things in this picture. One, there's only two threads. There's this 1, 2, 4, 8 thread, which I'm pointing at the wrong side. There's this 1, 2, 4, 8 thread, and there's this 3, 6 thread. And then there's this 5, 7, and 9 that don't play well with anyone. So any digit that's on a black dot can't be a 5, 7, 9 at all. But I want to show you something that's really nice, which is anytime you see 3 Kropki dots like this, or sorry, 3 cells that are connected by black dots, that's going to tell you a huge amount of information. Because it tells you there's 3 digits on the sheet somewhere that are connected. And you'll notice there's only one place that can happen, which is in this thread, the 1, 2, 4, 8. And in fact, actually, there's only 2 combinations of 3 digits that this could be at all. Namely, it could be 1, 2, 4, or it could be 2, 4, 8. Those are the only ways that you can get 3 dots connected like this. And so that tells you a whole bunch of things just from that. So these digits have to be from 1, 2, 4, 8. But better, and Andrew's already telling me the gotcha, and fortunately I picked a puzzle that has the gotcha that I can explain in a second. I'm not going to do bet cells during the tutorial. I'll do bet cells once we get to the next puzzle. But I'm going to try and keep the tutorial piece as clean as possible. We'll see how that goes. All right. Oh, there was definitely a similar sheet of paper for white dots. Don't you worry. So the middle digit is always a 2 or a 4. And so you can actually get rid of this 1 and 8. And actually, there's always both a 2 and a 4 included in these digits. And so the way we indicate that is by these corner marks. And so the center marks here mean I know whatever digit goes in this cell at the end of the day, it's always a 1, 2, 4, or 8. Yeah, people in chat, make up your own bet cell and bet. There you go. If you're excited for a bet cell, you can make up a bet cell and then you can bet on it. But I promise there'll be a bet cell once we finish this puzzle. So that tells me all of that, and it also tells me that the 2 and 4 within this box are in these, which is why they're corner marked. All right. So now Andrew pointed out an immediate, easy way to misstep with this piece of logic that I've just pointed out, which is these dots. And so you might be inclined to think I could do exactly the same thing with these 3 dots that we did with these 3 dots. Or 3 cells, I suppose. It's 2 dots, but 3 cells. But you can't, and the reason why you can't is that these 2 digits don't have to be different. So the punchline here really was this 3, 6 black dot was not on the table because I could not put 3 digits here. But I actually can use the 3, 6 dot here because I could go 3, 6, 3. Because I am not breaking anything when I do this. This is a super, super easy mistake to make, is to apply this piece of logic that I showed you in yellow over here in one of these places where it doesn't apply. And if you go back through the stream archives, you can find plenty of instances of me missing this. And I can think of at least once where Simon on Cracking the Cryptic got confused by missing this. It's super easy, but make sure you're only applying this piece of logic when you have 3 dots that see each other. Okay. But there's several places in this puzzle where we can apply what I'm going to call the yellow logic, and I'm just going to highlight them all for you. Oops. And then I'm going to lose my highlighting, which would be very unfortunate. Okay, so all of these places are strings where we can apply exactly the same logic. So all of these digits, they're all from 1, 2, 4, 8. And in all instances, the middle digit is going to have to be a 2 or 4. Note, if I tried to put a 1 in the middle, you can think about what that would do. If I tried to put a 1 in the middle, then that would put 2 2s next to it, because 2 is the only thing that connects to 1. Okay, so we've got all of that labeled. So that's the very first thing I would look for in any Kropki puzzle, is do I have any instances where I can apply this trick? Because quite often you will. Okay, now, this sheet of paper does keep on giving, because let's look at box 7. I have 3 of 1, 2, 4, 8 here. Okay, so again, going back to my picture, 3 of 1, 2, 4, 8 in this box, in box 7, are here. So what's this dot? Well, this dot absolutely cannot be from 1, 2, 4, 8, because only 1 or 8 is left over from here. And so the only things that can go here are 3 and... Sorry, I'm trying to point at this. The only things that can go here are 3 and 6. That is all that is left. So this is a 3, 6 going up here. Exactly the same thing happens over here. Because again, I've used 3 of my 1, 2, 4, 8 over here. So I get a 3, 6 up here. And let's see, is that might be all that I get for now. Okay. Now we should talk about white dots. And so, Josh, I think, jokingly asked if I had a drawing for white dots, but of course I have a drawing for white dots. And now, this drawing shows you all the possible white dot connections. But all the possible white dot connections, I've drawn this graph in a way that's probably not what you pictured. And I've drawn it in such a way to make evident the fact that the white dot graph, that is this diagram that I have here, it's bipartite. And now you don't have to really know what bipartite means, but secretly, most of the time in a Sudoku puzzle, when you get to color, it's because there's an underlying graph that's bipartite. And so what does that mean here? It means that there's this group on the left, the odd numbers, and this group on the right, the even numbers. And every zig and zag connects an odd number and an even number. Which means that when I connect from here, this cell is even. Automatically, this cell is going to be odd. And this cell is going to therefore have to be even again. Okay, which tells me what digit this is. Namely, it tells me that this digit is a 6. Okay, because 6 is even, and 3 is not. So this digit is a 6, is the punchline of that. And this digit's odd. In fact, you could, if you wanted, fill in that it's 1, 3, or 5, and I bet we'll know which it is in a second. By the way, Zach is off taking notes to the side because he's always been interested in the Sudoku stuff. So until the end of this, we're not going to... Sorry, I will try not to look away from the mic, Tristan tells me. Oh, I realize why. I keep looking away from the mic because I didn't pop out the chat because I was used to playing Outer Wilds. Whoop. There we go. All right. 1/2 second for me. Because I did not set this up. And Tristan is right. It will make the world better if I do this. Okay. There we go. All right. So we'll have to wait for a moment to get Zach's digit dances. But we have this. No, so if you're curious what happens, when I do Sudoku, I typically put the chat on top of the Sudoku grid. So you all in my grid that I'm looking at are where I am on your grid. But when we stream video games, which we've been doing lately, by the way, if you're interested in seeing Tristan and I play the Outer Wilds, we did that recently, and it was fun. Then you could do that. But if I'm playing Outer Wilds, that's full screen, so I have to put the chat over on the laptop, which is on a separate screen, and then everything is all weird and blah, blah, blah. Okay. So let's fill in what that gives us. So this is a 6, so this is a 3. And now this 6 is connected by a white dot to something that then connects to a 2 or a 4. And so the only option there is that this is a 5 and a 4. And now I can write down what these digits are. So they are the 2 digits that connect to 4, which are 2 and 8. And so now this digit cannot be 4, because there's a 4 in the row. And there's also this 2-8 pair, meaning that this can't be 2 or 8, because if it was 2 or 8, it would put too many 2 or 8s in the row. So now this cell is down to one option, which is to say it's a 1. And so once this is a 1, that then forces that this is a 2 and this is a 4. And once this is a 1, now this 1 is on a white dot relationship with this. Well, 1 and 8 are, and this is your fact of the day, 1 and 8 are not consecutive. So this has got to be a 2. That's an 8. And now this 4 over here I see is on a white dot with this digit, which means that this digit is a 3 or a 5, except it can't be a 3. So this is a 5. And we get to do lots more stuff, because now this 4 looks up here and gives me a 2. This 4 looks up here and gives me a 2. So these digits are not 2, and they're not 8 either, because 2 and 8 aren't adjacent. This digit here is not a 1 or a 2 by the column, but it is black dotted with 2, so it has to be a 4. It can't be an 8, so that's a 1. This digit can't be a 2 or a 4. Now, one thing that you will also notice about this is there's only 1, 1, or 8 in any string of 3 black dots that actually see each other. Again, I'm excluding this one over here from discussion. But because of my piece of the chart here, there's either a 1 or there's an 8. I can't include both a 1 and an 8. And so as soon as this cell is a 1 or 8, it actually tells me that this cell's not a 1 or 8. It's the other 2, 4. So I get that. I just say that because it's useful. I think it's probably not what you would see if you were looking at this, because this digit's a 1 or an 8. A thing that's really useful also to notice about the white dot picture that you're going to see used a lot is that anytime you have a 1 or a 9 on a white dot, that's super interesting, because 1 and 9 only connect to one digit. 1 only connects to 2, 9 only connects to 8. And so you should ask yourself, if you are about to put a 1 on a white dot, you should ask yourself, hey, can this really be a 1? Because if this was a 1, the consequence of that is it would immediately put a 2 here. And I see 2 separate problems with that. One is that there's already a 2 in the column, and the other is that there's already a 2 in the box. So this super can't be a 1. It's got to be an 8, 4, 2, like that. And so we've got all of our thing here. Okay, this will therefore be a 7 or 9 because it connects to 8. All right. Now there's something interesting about this cell, which is that this cell sees in its column 1, 2, 4, and 8. And it sees in its column 1, 2, and 4, and it sees in its box 8. So this cell, if I just look at what this cell is allowed to be, it's not allowed to be anything from this string, which means it can only be one of these two. It has no other options. So this is 3, 6, and therefore this is 3, 6 because it connects to it. But I actually know the order because this 3 looks up here and tells me that's going to be a 6 and a 3. And this is going to be a 5 and a 7. And so we have that additional piece of information that we can fill in. Okay, let's look at this cell. Anytime something is on a white dot, you should fill it in. So for example, I should have noticed a long time ago, but I didn't, that this 3 is next to a 1 or a 4, but it's got to be a 4 and a 1 going there. No choices for that. So we have that. I want to fill in this one. This has got to be a 1 or a 3. Now, for a very similar reason, this can't be a 1. If you're just showing up, I'm trying opening with a sort of like intro to Kropki. So I'm going to do a few easier Kropki puzzles, and then we'll get to the normal insanity that is this stream. So this is a 1 or a 3, but if it's a 1, then this cell has to be a 2, which is already in the row. So this can't be a 1. So this is a 3. And therefore, this is the only digit that black dots with 3, namely 6. Which means these are the 2 digits that play nicely with 6, namely the 2 that are consecutive. So this is a 5-7 pair. And so we get all of that going on right away. All right. Now what do we have going on? Now 3 is placed in this box. So what's going to very often happen in these puzzles is you're going to have lots of Sudoku stuff on 3s and 6s and 2s and 4s. In this instance, 3 is ruled out of all of these cells by the row, and it's ruled out of these cells by the columns. And so 3 is now placed right in the center here, which is nice. I also can ask myself a similar question about 3 in this box. And so 3 in this box, if you just look at it, well, it's, spoiler, 3 is not 1, 2, or 4. 3 can't go here because there's a 3 in the column. But actually, if you look at it, I can't put 3 on this white dot at all either. And that's a thing you should pay attention to. Because 3 is only adjacent to 2 and 4, but 2 and 4 are already gone in the box. So if I put a 3 on this white dot, I have broken the puzzle. So I can't put a 3 on this white dot either. And so none of those are 3. That's not 3, that's not 3. So that is a 3. And now we can sort of bounce down to this box. That's a 3, just by Sudoku. And if I now come over here in this box, 3 is, I guess, in one of these two spots. I'll go ahead and do that. Gas chaos construction when? Yes. There was a while ago where Clover, who's one of the regular constructors of the gas puzzles, was asking who would the scariest gas guest setter be, and it was definitely, for me, it was definitely today's gas guest setter is either totally normal cat or Glipperal. I think those are the most terrifying of potential gas guest setters. So this 3 goes ahead and puts a 6 over here. Puts a 3 there. That means that there is a 3 in one of these two cells. Gas Little Killer by Glipperal. Oh no. Oh no. Alrighty. Hey, Omega, how are you? Alrighty. So I like to start just filling in digits once I have 5 things, just so I don't miss anything. So this is a 5, 7, 8, 9. These aren't 5, so these are from 7, 8, 9. Let's see. These digits are 1, 2, 3, 4, 5, 6, 7, 9. 1, 7, 9. If you look closely, these can't be 1, so in fact, that's the 1. I'm doing well. I am having fun doing this, this lovely little gas puzzle. So now... these digits, if I look, I've got the 7 and 9 in the column. So these are from 2, 4, 5. And then we've got 6, 7, 8, 9 down there. This one's not 2. This one's not 4. But here's a neat thing about that. This is a 2, 4, 5 triple. So the 5 is definitely in here. So this can't be a 5 in the box. And so that's a 7, which then actually goes and does more damage because it comes over here and means that's a 5. So now that's a 7. That 5 bounces back and means that's a 2. So this isn't a 2. Now, I've got here 7, 6, 5 blank. So this had better be a 4. Or bad things are happening. That 4 sees over here and makes that a 5 and a 4. These aren't 7. I'm going to go ahead and update while I am noticing it. This is 2 or 8, but I don't think it's resolved yet. These 3 digits over here are 1. We've got a 2, 3, 4. We need a 5. No, we don't need a 5. We've got a 2, 3, 4, 5, 6, 7. These are 8 and 9 is what these are. This one is not 1. Somehow, strangely, I think we don't know anything about the rest of this. I'm about to, though, because up here, what do I need? In row 1, I need a 1. Well, in row 1, I need a 1. I've got a 2, 3, 4. I need a 5. I've got a 6, 7. I need an 8 and a 9. This isn't a 1. Neither of these can be 8. That one's not a 5 either. So now, actually, if you look at this and ask, where does 5 go in row 1? You now actually get that this cell has to be the 5. Because another way to say that, if you want, is that this is a 1, 8, 9 triple. So that's a 5. In order to make this work. Let's see. So this column now only has a few things left in it. So let's fill those in. So we've got 1, 2, 3, 4, 5. We need 6, 7, 8, 9. This isn't 7 or 8. It is 6 or 9. This isn't 6. In fact, actually, when I see that this digit is 7, 8, or 9, it makes me very suspicious. Because this digit's very high, and a thing is, if you're consecutive with a digit that's very high, that means this digit's also very high. So this digit's also going to have to be a 6, 7, 8, or 9. Because if I'm adjacent to a 7, 8, or 9, this has to be a 6, 7, 8, or 9. Except this digit's not 6 or 8, because it sees a 6 in the row and an 8 in the column. But now once this is 7 or 9, this can't be 7 or 9, because 7 and 9 are not consecutive. So this is actually an 8. And that's going to do yet more damage, because I now have a 7-9 pair in this column, so this can't be a 7 or a 9 anymore. It's a 1, meaning that's not a 1. That's an 8-9 pair in the box, so this is now a 1. Let's see. So these, of course, aren't 8 anymore. I now have a 7-9 pair in the row, so this isn't a 7 or a 9, so it's a 5. So this is not a 5. This is certainly not an 8 anymore. That's not an 8 anymore. It's also not a 6. Gives me a 7-9 pair in this row, which is not super interesting, I suppose. This black dot has got to be very interesting, in particular this digit. So this digit here, actually, if you look at it, it sees 1, 2, 4, and it sees 3, 6. So again, sort of go through your mental checklist. That's all but one black dot digit. So in fact, that means that this digit has to be an 8. 8 is the only black dot digit that can go in this cell. Every other one has been eliminated. And that's something you'll see a lot in these sorts of puzzles as well. So that makes that a 4. Now, this is the dot we talked about earlier as being able to make sort of a crucial mistake, which is that if you sort of do this without thinking, you might go ahead and fill in a 2 here. But if you do fill in a 2 here, there's a pretty serious issue, which is that these two are the same digit. So this actually can't be a 2. This is an 8. So in fact, the problem that Andrew immediately highlighted when we started talking about these did actually come to fruition. All right, so that 8 down there sees up that that's a 2. This digit now has to be a 1 or a 3 because it's next to a 2. Well, it's not a 3 for a bunch of different reasons, so it's a 1. And that's super convenient because it now makes this a 2. This is now a 4 for lots of reasons. Take your pick of which reason you like. And now this 1, 2, 4 here has again forced this black dot to be 3, 6. Because, again, once I've used 3 of 1, 2, 4, 8 in the box, I can't use a 4th of 1, 2, 4, 8 on another black dot. So this has to be 3, 6. But I already know the 3 in this box is in one of these two cells by my pencil marks, so that's the 3 and that's the 6. So then by my pencil marks down here, the 3 could only go in one of these two cells, but we now know which one. It goes there. So we have all of that. Let's fill in these digits. We need a 1. We've got 2, 3, 4, 5, 6, 7. We need an 8 and a 9. These aren't the 8. So that's the 8, giving me a 1, 9 pair in the row, meaning that that's the 6. Meaning this digit here is a 7 or a 9 to finish off this box. This 1 sees up, making that a 9 and a 1. These 3 here are 2. We've got 3, 4, 5, 6, 7, 8, 9. 2, 5, 9. So this now, just by Sudoku, this is a 9. This is not a 5 or a 9, so it's a 2, and so that's a 5. This digit is a 7 or a 9 by the row. So now this box only has one digit left because it's got a 7, 9 pair in it. You're going to see, by the way, quite often exactly what's happening here will happen, which is that you have lots of 5s, 7s, and 9s sort of floating around in the grid. And, oh, nope. Nope, I did that wrong. Thank you. There's not a 7-9 pair here. Thank you, Jaleb. So this is much better, in fact, than what I was going to say. I'll finish what I was going to say, and then I'll do it right, which is that often you'll have lots of 5, 7, 9s floating around to disambiguate at the end, because 5, 7s, and 9s are completely agnostic to black dots. And since black dots are more powerful than white dots, often what will happen is you'll sort of lock in all the 1, 2, 4, 8, 6, 3 sorts of digits, and then the 5, 7, 9s have to get sorted out at the end of the day by white dot stuff. Okay, now let me do this correctly. This 9 sees this digit as a 7, and that digit's a 9, and this digit's a 7. And so this is a 9. Okay. Better. Thank you, Jaleb, for catching that. Got 1, 2, 3, 4, 5, and this digit's a 6. And so you've got 1, 2, 3, 4, 5, 6, 7, 8, and this is a 9. Let's see. Let's finish this row. It still needs a 1. Let's see. This box still needs a 6 and 7. So that's a 6 and that's a 7. There's a 9 in this box. So that's a 7 and a 9 and a 7. That 7 looks over and sees that that's a 9 and 8 and a 7. 8 looks up, gives me a 9 and an 8. These digits on this white dot are a 5 and a 6. 6 has to go there, and the 5 goes there. Nicholas won his bet cell. That is delightful. 1, 2, 3, 4. Okay, so we need a 5 in this column. It has to go there. 6, and so then we need a 7, so the 7's going to go there. And so then I got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now we've got 1, 2, 3, 4, 5, 6, 7, and we need an 8. That is the puzzle. All right, so I think that is most of the techniques that you're going to see over and over again in Kropki puzzles. Okay, now I did want to actually sort of reset the puzzle and point out something that a lot of people in chat were saying that's a more advanced technique that I noticed when I first looked at the grid and assumed would not come up because it's a gas puzzle. But there's something you could notice when you first look at this grid that might raise your alert level if you're doing a more advanced puzzle, which is that I've got these two things that both have to be from 1, 2, 4, 8. So that means they both have a 2 and a 4 on them. And the question is really always going to be, when you think about this, are these two the same or are they different? And now in our solved grid, it turned out they were the same collection of digits. But quite often what will happen in a puzzle where you have a setup like this is it'll turn out, because of the information up here, it's not possible that these are the same set of digits. And here's the reason why, and this is what lots of people in chat were talking about. If these are the same set of digits, so, well, then where do those digits go in this box? Well, then they go there, which is what ended up happening. They went exactly there. And then actually, if you knew that that was what happened, that actually then tells you, well, I need to have a 1 and a 2 in here, and it's going to go 1, 2, 4, and you can sort of do that. And that's what's called roping. And so if you were seeing people talking about that in chat, that was what they were noticing. You will... I think that would be a very common break-in for a 3-star Kropki puzzle, would be to note that kind of thing. All right, so let's do a couple more of these. And so we're gonna look at a couple more sort of gas level Kropki puzzles, and then we're going to look at the slightly harder kuraban Kropki puzzle. So let's again sort of immediately ask ourselves about strings of 3 black dots that see each other. And so we get lots of those, which is very generous. So the middle one is always a 2 or a 4. And we have this given digit doing work right away, because this 2 in the box tells me that this 2 or 4 is not a 2. So this is a 4. And now this digit is in a black dot relationship with 4, but it's not a 2. So this digit's an 8, and that's a 2. So we get to use our fancy givens. Now here there's something really cute going on. Could this center digit ever be a 2? And the answer is this center digit could never be a 2, because what happens if this center digit's a 2? Well, then these digits are the 2 digits that Kropki a 2, which is 1 and 4, and these 2 digits are the ones that white Kropki a 2, which are 1 and 3. Except you'll notice that what just happened in that universe is that we put 2 1s in the box. And we should not put 2 1s in the same box of a Sudoku if we want the answer correct. So this actually, for reasons that are cute, can't be a 2. It has to be a 4. And the exact same argument applies here, and the exact same argument applies here, because of this little constellation shape that we have here. So these digits are a 2 and an 8, and I'm noticing for the first time we have a given 8 in the south of the grid. So the given 8 actually tells me that this is an 8 and a 2. These are a 2 and an 8. We have a 2 up there, so that's the 2 and that's the 8. And we can go ahead and fill in all of these things. These are all a 3-5 pair, which is cool. Okay, so that is sort of lots of stuff happening at once. All right. So we've got all of that. So let's fill in other things, like this has to be a 1 or a 3. And let's fill in the rest of the digits in this box. So the rest of the digits in this box, and the reason why I'm doing this is because I'm particularly looking at what's going to happen with this white dot. I don't know yet, but it looks sus. So I need a 1. Got 2, 3, 4, 5. We need a 6, a 7, and we've got an 8, and we need a 9. Okay, so I want to immediately ask myself what this digit can be. If this is a 1, then this becomes a 2, which does not work because there's 1 in the column. If this is a 9, then this becomes an 8, which does not work because there's 1 in the column. So this digit's a 6 or a 7, which means this digit's adjacent either to 6 or 7. So this digit has to be a 5, a 6, or a 7. Notably, it cannot be an 8 because there is already an 8 in the row. By the way, I should fill in that this is a 7 or a 9. So we have that. Okay. This looks like there's something almost going on. Yeah, there's something going on here. The thing that's going on here is that this collection of digits will never work if I don't include a 6. And so there's a bunch of different ways to think about that, but the way I'll encourage you to think about it is every white dot, because of the sort of the bipartite magic graph I showed you earlier, every white dot has an even digit on it. We've completely pencil marked these 2 cells, and the only even digit that can possibly exist on this white dot is a 6. And so one of these 2 digits is a 6. I'm going to be slightly naughty, and I'm going to pencil mark this across boxes. So normally corner marks would mean one of these 2 digits in this box is a 6. In this instance, I've highlighted this in green to remind myself that it is it's the green cells that I'm saying one of them is a 6. So that has a couple consequences. One is that that's not a 6. And the other is that this black dot has become a little spicier. Because this black dot now can't have a 6 on it. So it can't have a 3 on it. We've cut off the 3-6 branch. It also can't have an 8 on it. So this dot is from 1, 2, 4 only. This one's not a 4. In other news, this one's not a 1 either. Because if this were a 1, that would be a 2, and that's no good because there's a 2 there. So this digit, in fact, is a 2. This digit's a 4, therefore. Or sorry. Hold your horses. This digit's a 1 or a 4. I don't know which. This digit's a 1 or a 3, but it's not a 3 because the column has a 3-5 pair in it. So this digit's a 1. So that digit is a 4. That was correct that time. So we have all of that sort of filling its way in. And now this cell is interesting again. Because now this cell is in the 1, 2, 4, 8 strand, right? It's got a 2, 4 in the middle. So these digits are all from 1, 2, 4, 8. But this one can't be 1, 2, or 4. So this digit is an 8. And that's great, because as soon as it's an 8, it lets me fill in the entire rest of the thing. That's a 4, that's a 2. And then we get another 3, 5. I like that this puzzle has a very clear theme, which is these magical 3, 5 hoobly-hoos are very cool. Okay, I should fill in what these digits are, by the way. I don't know why I never did. These are 2 or 8. And it's great that I've filled those in, because now I see that this 8 actually gave me the 2 and the 8. And so we have that going on. And so now I'm going to fill in the rest of these digits. And again, I'm doing that because I see that 2 of these are on dots that are likely to be very constrained. So the digits left in this box are 1. We've got 2, 3, 4, 5. We need a 6, a 7, and a 9. Okay, this digit, let's start with that. It can't really be a 1, because that would put a 2 here, and there's already a 2 in the column. I think, actually, it can be any of these other things, if I squint at it. At least, oh! Not if I fill in this. This is a 3-5 pair. That will help me a lot. Because this 4 is only adjacent to 3 and 5 in the column. I just never filled it in, despite talking at length about how there is this 3-5 pattern. Okay, so maybe that doesn't actually immediately do me any good. Let's look over at this dot. So there are 2 things I see immediately it is not. It is not 7 or 9, because 7 and 9, remember, are in their own little magical Kropki bubbles. They don't black dot with anything. So this digit is a 2 if that's a 1, and it's a 3 if that's a 6, is what I am seeing. I am looking at just Sudoku stuff. So where is 4 in box 6? So 4 in box 6 is over in this column. It's there or it's there. And now that's exciting because both of these 4s are on black dots. And it's even more exciting because this 4 is broken. This 4 can't actually... this 4 can't be the 4, because then this would need to be a 2 or an 8, and it can super be neither of them. So in fact, we actually get that this is the 4. And so now this is a 2 or an 8, but it's not a 2, so this is an 8. So we get that. Okay, so this digit I now want to try and force. And the reason for that is because I see it sees lots of 2, 4, 8s. It sees all of 2, 4, and 8. So if this cell wants to be one of the 1, 2, 4, 8 gang, then what digit does it have to be? It has to be a 1. But that doesn't work, because then this is a 2. So in fact, these are a 3, 6 pair. For sure. I now want to use something ridiculous. But I probably shouldn't. But I think... Okay, so I'm going to anyway, even though I'm sure this is not the intended thing, but I think it's cool enough that I'll go over it. In this pair, one of these 2 is a 3. In this pair, one of these 2 is a 3. So what that means is I need to have a 3 in one of these 2 cells. Because what if neither of these is a 3? Well, then both of these are 3s. And that's a problem because I've put 2 3s in a box. So actually that gives me sort of a... Oops. That gives me a 3-corner mark here and a 3-corner mark here. And those do me 2 really cool things. So one is it tells me this can't be 3 anymore. Because again, if this were 3, that would tell me these aren't 3, and now both of these are 3 in the same box. That's not great. So that's a 2, and that's a 1. These 3s also look over here, giving me a 5 and a 3. That 3 looks over here and gives me a 5 and a 3. And so that gives me some more joy out of these things. Let's see. So this isn't a 1. Actually, neither of these is a 1 anymore. They're 6, 7, or 9. Let's see. I'm being told that row 4, column 7 is given. Well, we have now gotten it. I now see the way that we could have gotten this that was much simpler than the way I did, which is that there was a 3-5 pair looking at this cell that I had pencil marked as 2 or 3, which is, very close. Hey, Nordy, how are you? So it's now being pointed out that I have placed 8 2s in the grid. And so anytime I've placed 8 2s, it should be within my power to place the last one. So the last one has to go here. It's the only place Sudoku-logically that it can go. And so this digit has to be a 1 or a 4. I don't think I yet know which. There's a 3-5 pair in this column while we're pointing out 3-5 pairs. The 3-5 pair in this column looks at this cell and makes this cell a 1. Also, the 3 in the box looks at that cell and makes that cell a 1. Whichever way you want to do it. And let's go ahead and fill in the rest of these digits. So we've got 1, 2, 3, 4. We need a 5 and a 6 and a 7 and a 9. And now let's cross-examine this cell. This can't be a 9, because if this was a 9, this would need to be an 8, and it can't be. And so if this is a 5, this would have to be a 6. If this was a 6, this would have to be a 7, because it can't be a 5. And if this is a 7, this cell would have to be a 6. So in fact, this cell is always a 6 or a 7. And we've actually repeated exactly the same pattern that we had over in green over here. We've repeated it up here. These are from 5, 6, 7. And so because I need an even number, one of them has to be a 6. And so we can strike out those 6s from those two cells. And then we can examine what's going on in this column. Here's one thing that's going on in this column. I've pencil marked a lot of cells, and I've only pencil marked a 4 here. Well, that can't be a 4. So this has to be a 4, just for the column. There's nowhere else. How many 4s do I have? I now have, 4 is placed here, just by Sudoku, because I've got 4 4s looking into the box. So that's a 4. So this is a 2 or an 8, except it's not a 2 by the row, so it's an 8. So this is a 7 or a 9. What's going on in the rest of this column, actually? We've got 1, 2, 3, 4, 5. We need a 6. We need a 7 and a 9. Okay, so these are from 6, 7, 9. I don't think I immediately get to rule out any of those, unfortunately. But hey, it's good to know. Let's see. Where else should we look? I probably should look at this cell also, maybe, possibly. No, I should look at 8. Where does 8 go in this box? That's a good place. 8 and 8, look into this, placing an 8 here. Oops, placing an 8 there. Which means this isn't a 6 anymore, because 6 and 8 are not adjacent. How am I doing on 8s? I seem to have 9 8s, which is sort of the worst possible answer. I was hoping I would get to place an extra 8, but I did not get to place an extra 8. Let's see. This 5 is looking up here, saying that's not a 5, while we are penciling these things in. Let's see. Oh, did you think I was still on the previous puzzle? It's not quite going that. It's not going that slowly. I'm on the second puzzle already. I mean, I feel like 15 minutes for a gas puzzle with heavy amounts of explanation isn't too bad. Because I think we're almost done this one. There's a 3-5 pair looking up here, so that's not a 5. Well, Well, you know, probably paying attention to work is a profitable thing to do, even if Sudoku is more fun than work. Let's fill in these digits. So we need a 1, we've got a 2, 3, 4, 5, we need a 6, 7, 8, and 9. Yeah, but this one has these this cute little plus theme, so I wouldn't quite say this is quite the same puzzle. These aren't 1. This can't be a 9 because it would make this an 8. Are we going to get exactly the same pattern again? We're going to get exactly the same pattern again. This digit is a 6 or a 7, meaning that this digit is a 5, 6, or 7. And so I can do the same trick. Again, one of these has to be a 6. So this digit's not a 6 and that digit's not a 6. So yet more magic. Let's see. Let's look at 1s. 1 is a smart digit to look at, because I've not yet examined 1s. But there's going to be a lot of 1 placage, I suspect, because 1 now, if I look in box 9, 1 goes here. Let's hope for more 1 placage. I know one of these two is a 1. That doesn't quite tell me anything. Yeah, okay. So I know one of these two is a 1, just by Sudoku. Those aren't 1. That's not 1. These aren't 1. So one of these two is a 1. And so now I ask, where does the 1 go in box 6? And now the 1 in box 6. Now, because the 1 in row 5 is over here, this has to be the 1 that's in box 6. That's not a 1. So now this is the 1 in box 3. So now I need a 1 in box 2, and the 1 in box 2 now has to go here. And now do I have all the 1s? Not quite, almost. Very nearly almost. I know that's not a 1 anymore. And that not being a 1 anymore is huge, because now there's a 7-9 pair down here. And so now that there's a 7-9 pair in this row, that tells me this digit can't be a 7. It's a 6. And this digit can't be a 7. It's a 5. And that's going to give me my 3 and my 5. And so that is going to percolate, I believe, maybe possibly in some fashion. Maybe not. Maybe it will do absolutely nothing. That's also possible. Well, I know this isn't a 6. Let's fill that in. This is a 1, 7, or a 9. Sure. Oh, same in row 1. Beautiful. Okay, yeah, same in row 1. We've got a 7-9 pair here. And so we get this 6, meaning this is a 5 now, because it can't be a 6 or a 7, so it's a 5. That is cute. So this isn't a 6. So now this has to be the other 7 or 9 for this column, because the column needs 2 7 or 9s. That's the only place the other one can go. Let's see. Look back over here and look at this column. And so chat is suggesting a very wise observation, which is that in this column, I have not pencil marked a 3 anywhere. And so this has to be the 3. So that's a 1. So we get that. Let's see. Oh, this 5 gives me a 3 and a 5. That's something else I should probably have noticed. So this 5 now comes over here, means that's not a 5. This is a 6, 7. That's going to do a lot, because that's going to give me a 9 here, which is going to give me a 7 here. These two aren't 9 anymore. That one's not 9 anymore. It's also not 7, owing to the 6, 7 pair, so that's actually a 5. So I've got a 6, 7, 9 triple in row 3, which means that this digit is given. So this digit has to be a 3. It's the only digit left in the row. So this is a 6, 7, or 9 as well. I don't know that I really want to pencil mark that, but here I go. I'm pencil marking it anyway. Let's see. This 1 looks down here and gives me a 7 and a 1. And the 7 down there gives me a 9 and a 7. 7 gives me a 9. That gives me a 7 here. This isn't a 9 anymore. Let's see. Let's squint carefully. So I need a 9 in one of these two cells, which is, I guess, not surprising, because I know that these are a 6, 7, or 9 to finish off the box. This is a 6, 7, or 9 to finish off the column. What digit am I missing from this? It's not a 6, 7, or 9. I'm missing a 3. Yeah, one of these two is a 3, but I don't think I know which one yet. That's disappointing. I'm being encouraged to look at 5 doku. Ah, yes, 5 doku. 5 doku is correct. This 5 looks here and makes that a 3, which is going to resolve everything, I presume, because that's a 3, and so now that's a 6, and that's a 3. That's not a 6 anymore, so now this is the 6. This 6 looks over and makes that a 7 and that a 6. Makes that a 9. Makes that a 6. That's a 7. So that 7 looks over and makes that a 9. So this isn't a 9. That's not a 9. What are these two digits? We got 1, 2, 3, 4. We need a 5, which needs to go there. And we've got 6, 7, 8, and we need a 9, which now goes there. This column now is done. We've got 1, 2, 3, 4, 5, and we need a 6. This column is done. We've got 1, 2, 3, 4, 5, 6, 7, 8. We need a 9. So that's a 9. This 7 looks over and makes that a 6, and that a 7, and that a 6. This row needs a 9 still. So that's a 3. And that's a 7, and that's a 9. This digit is now not a 6 or a 9, so it's a 7. And we finished the puzzle. Very nice puzzle. I liked the little plus theming. Alrighty, so let's do one more Kropki gas puzzle, and then we'll do Kuraban's Kropki puzzle, and then we'll do the voted on directionary puzzle. So directionary is on deck after the Kropki stuff. All right, so here's our next Kropki journey. So if you have been paying attention to how often this pattern has been helpful, it's been a lot. Oh, there's one more even. These are all our digits where I know they're 1, 2, 4, 8. And I know the center cells of all of them are 2 or 4. So they're not 1 or 8. This dot has to be 3, 6. 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 And all of these are 3, 6 because they're a black dot that sees 3 of 1, 2, 4, and 8. And so, again, by our little diagram, the only way a black dot that sees 3 of 1, 2, 4, and 8 can possibly work is for it to be 3, 6. So we've got lots of stuff going on here. Now what should we do with our lives? So this column I need to fill in these white dots, and I need to do that very carefully, because remember, every one of these yellow things has both a 2 and a 4 on it. And so there is no 2 or 4 here. So what digits could possibly be in this string? Well, naively a 1 could be, but there's no 1 in these strings, because if there's a 1, there'd need to be a 2. That's not going to work. So there's no 1. There's no 2. There's no 3 in here. There's no 4, because there's a 4 up here. There's no 5, because actually 5 isn't connected to 4 or to 6. There's no 6, because there's a 6 in the column. So in fact, actually, these are just immediately a 7, 8, 9 triple. That's the only possible string of 3 digits. And now when I see this pair, I can resolve a whole bunch of stuff. Because the only of 7, 8, 9 that's adjacent to a 3 or a 6 is a 7, and so that's a 6, and that's a 3. It's an 8 and a 9. So the 3 now is only connected to 2 and 4, except I know that these aren't 8 anymore. So once I see that, then the 1, 2, 4 triple here, what goes in the middle of a 1, 2, 4 triple of black dots? Well, the digit that goes in the middle of a 1, 2, 4 triple of black dots is 2. Sorry, is 2. There we go. So this is a 1, 4 pair. 3 is not next to 1, so that's a 4. Wow, that was bad. So that's a 4. Take 3, and that's a 1. At this digit we now know, 1, 2, 3, 4. This is a 5. And now let's look Sudoku-logically at the rest of what's going on in the universe. Because that 4 now bounces over here and tells me that that's a 2. So this is now a 1 or a 4, but it's not a 1, so it's a 4. Therefore, that's a 1, because 4, 2 has to then chain on to 1. 4 isn't next to 6. 4 is next to 3, so that's a 6. That 3 now looks over here and gives me a 6 and a 3. Let's see. I know this isn't a 4 or an 8 or a 2. And so not being a 4, 8, or 2 is very helpful. It just makes this a 1 immediately. So that's a 1, 2, and 4. Okay. What about this 6? What's going here? Well, it's not a 5, because there's a 5 in the row already. So that means this is a 7. And then once I have gone from 6 to 7, then the rest is forced. So that's an 8, 9. That's a 5. Now here, now there's a 5 in the row, so this 6 can't connect to a 5. It's got to go 7, 8, 9. And that's a 5. So things are happening. We like it when things are happening. This 6 looks up and makes that a 3 and a 6. These are not 8. Now, here's an instance where I can actually show that this can't be 5 for a different reason. I've got this sort of Z swish of white dots, which means as soon as I pick what this value is, it's going to force all of them. So this is a 5 or a 7. But if it were a 5, I have to think one step ahead. If this is a 5, now this is a 4. But that's a problem, because this is a 1, 2, 4 triple. So that doesn't work. So actually, this is a common thing, and so this is very, very equivalent or very similar to Renban logic, which I assure you there will be a Renban day at a later date. Those of you who know me will not be surprised. This can't be a 5 because it would break this dot. So in fact, this is a 7, 8, and 9. So once we've got that, well, we now know that these are, so we now know that that's a 5. Let's see. So that is not an 8. That's not an 8. So now this is a 1, 2, 4 triple. And so we can do the same sort of trick about thinking about what's going to happen. If this is a 3, then this would have to be a 2 or a 4. Except I've got 1, 2, 4 in the box already. So this can't be a 3. In fact, this is a 6 and a 3. And now we can do the same trick. Actually, we can do it even easier. There's already a 5 in the row, so this can't be a 5. So it has to be a 7, 8, and 9. And that's a 5 to finish off the box. It is a 2 that goes in the middle of a 1, 2, 4. Similarly, over here, I should have said this a long time ago. It is a 2 that goes in the middle of 1, 2, 4. So none of those are 2. And so let's look at more Sudoku. So there's a 5 missing in this column. So that's got to be the 5. This I know isn't a 1. Now, I can never actually put a 3 on this white dot, because remember, this is going to be a little bit different. But remember, this trio, it always has a 2 and a 4 on it. And so because it always has a 2 and a 4 on it, I can never put a 3 on a white dot in this box. So this has to be a 6. And so now that's a 3. And so that's a 7, 8, 9. And so these are not 8, so that's not 8. So that's a 1. And so then now this is a 2 and a 4. Chad is pointing out that I actually know how this works out, because that's a 4 and a 1. I should pay attention. That's a 1 and a 4. Actually, exactly the same pattern was over there. So now I should look at these cells over here, probably. Actually, let's just fill in. Let's fill in these. Do I want to start up there? Let's start up here. So we're missing a 2, a 3, and a 4 in the row. So this digit is not a 3 or a 4, so this digit's a 2. So these aren't 2, those are a 3, 4 pair. Here I'm missing a 1, 2, 3, 4, a 5, a 6 is what I'm missing. So this isn't a 6, that's not a 1, that's not a 5. Useless, all of you. This is a 1, 2, 3, 4, 5, 6. This is a 7, 8, 9. So that one's a 7. These aren't 7. All good. Let's see. Okay, how about down here? We've got 1, 2. We need a 3. We've got a 4, 5. We need a 6 and a 7. These are 3, 6, 7. So that one's the 3. These aren't 3. That might be useful in just a second. This one is, we've got a 1 we need. We've got 2, 3, 4. We need a 5. We've got 6, 7. We need an 8. So this one's an 8. These aren't 8. They are 1 or 5. This one is, these are 2, 4, and 9. That one's not a 2. That one's not a 4 or 9. So that one is a 2. So that one's not a 2. Okay. So let's let's use this to press some Sudoku over into this box. Let's see. So I've got 8 is pressed into one of these two cells. That seems useful. Not super useful, admittedly. I'm going to be doing these tutorial days either, I think, weekly or streamly, depending on how popular they are. But at least once a week is the plan. Because I think these will be very useful to point back to point people back to. 2 in this box goes here. Have no real choices about that. Let's see. What about 3s? 3 in this box goes none of these places. Not there. Sadly, I don't know if... I know one of these two is a 3, but I don't know which one. I mean, we're going to be doing this for, an hour and a half, and then we're going to be doing our usual range of difficulties of puzzles. So don't worry, if you really crave very difficult puzzles, there will be plenty of difficult puzzles today. Let's see. We need a 1. We've got 2, 3. We need a 4, 5. We've got 6, 7, 8. We need a 9. Okay, let's just write this in. So this is not 4. This is not 1. Just to think about that. This column, let's fill in this column. So this column, we need a 1. We've got a 2. We need a 3, 4. We've got a 5. We need a 6, and we've got a 7, 8, 9. Okay, maybe this cell will do it. That's not a 3 or a 4. So that gives us a 1, 6 pair in the column. So this isn't 1 or 6. It is 3 or 4. I don't know which one yet, though. My ability to fill every cell except the useful ones is astonishing. I'm glad I can impress. I do feel like I'm getting very unlucky with this one, but maybe I'm just not being sufficiently observant. But let's see. 7 in box 7. Okay. Yes. 7 in box 7 seems very helpful because 7 in box 7 is here. And so 7 in box 7 means that these digits are from 6, 7, 8. And there's not a 6 in them. So these digits are 7, 8. And that's going to do everything. Let's pencil mark all the clues except the ones... Well, it didn't look like these were going to be useful. I actually don't think pencil marking these would have been useful. I really needed to just look and find that 7 was being forced here, which I should have looked at because 7 doesn't go on a black dot at all, and that would have given it to me. Anyway, this is now all going to unravel very quickly because that 8 is going to give me a 7 here, an 8 here. That 7 is going to give me a 6 here and a 7 here. Now this black dot can't be 1, 2, 4, or 8. So it's got to be 3, 6, and we know the order. So that's a 1 and a 5 and a 1. The 3 gives me a 4 here. That 4 gives me a 3 there. The 1 gives me a 6. That's a 4. This is not 1. This is not 4. This is a 5, 9 pair. So that makes that a 4 and that a 9 over there. Let's see. This 6 gives me a 5 and a 1. The 5 gives me a 9 and a 5. The 9 gives me an 8 and a 9. And then we are done this puzzle. Alrighty. Gas puzzles are fun. I really enjoy the gas puzzles, by the way. If you don't do the gas puzzles, by the way, I really recommend that you give them a try. They're very snappy, and they have this sort of like video gamey feel to them, where they're not really trying to do something like super fancy. They're really trying to sort of get you into this flow state where just the deductions just sort of topple one after the other like dominoes, and it's so satisfying. All right. So my goal for all of these is to pull up a 2 or 3 star puzzle at the end. And so this is a 3-star kuraban puzzle. So we're going to look at this. And so this is going to be a little bit harder than the gas puzzles, probably. By the way, to all of you in chat, there is a vast shortage of 2 or 3 star puzzles that only use one constraint by people who I know. So if you are interested in making a puzzle for stream that could be used in one of these tutorials, I really recommend try and make a 2 or 3 star puzzle that uses only one constraint. Because if you do that, then I will very likely do it. So post it on LMD, make sure it gets rated 2 or 3 stars, preferably 2 stars, but 2 or 3 stars, only one constraint, and I will use it for a future tutorial series on whatever the constraint is. So anyway, so if you want to both get your puzzle featured and decide what constraint I do a tutorial series about, that is a great way to do it. I did my best digging to find them, but I did not find a lot. All right. So here's an advanced trick right off the bat. So here's a trick we've not seen in the gas puzzles. I mean, maybe it was there and I just didn't see it, but this is a trick you'll see in sort of fancier Kropki puzzles. Again, you can look at the little sheet. There are 6 yellow cells here on black dots. And there are only 6 digits that I can place on black dots. And so what that means is these digits have to be the others. These are 5, 7, 9. And so very often in Kropki puzzles, you'll see either a row, a column, or a box, or maybe more, where there are a total of 6 digits that appear on black dots. And whenever that happens, you know that everything else is a 5, 7, or 9. So I'm going to just highlight everything that's on a black dot and just scan to see if that happens anywhere else in this puzzle. I do, by our earlier argument, know that that's a 2 or a 4, and that there's a 2 or a 4 elsewhere here. Okay. We have here, we have some interesting stuff going on here, actually. So here's a very interesting arrangement of stuff. Set a fun 2-star Renbon puzzle, I'd be delighted. So here, these are both odd. So by the magic of the white diagram that I sort of emphasized about the sort of parity coloring business, these 2 digits are odd, so both of these are even. So what are they? Well, they can't be 3, 6, because 3 and 6, spoiler, not both even. So they're either 2, 4 or 4, 8. But actually, and this is another trick that shows up a lot, these are not 2, 4. And the reason why these aren't 2, 4 is that I need to make 2 more black dots in this box. How am I going to do that if I make this 2, 4? Well, if I make this 2, 4, I'm going to need to make one of these black dots 1, 8. That's going to go very badly. And so actually, because of parity, these need to be 4 and 8. And so if these are 4 and 8, that's going to give me a whole lot of stuff. So one thing that it's going to give me is this. This can't be a 4, because if this was a 4, these would be double 5. So this is in fact an 8. So that's a 4. These are 7, 9. And this is a 5. Now, as was pointed out in chat, this was not the only place where that black dot trick that we opened with started, because in column 2, we also get that trick. In column 2, there are 6 yellow cells. There are 6 cells that are on black dots. Those are all from 1, 2, 4, 8, 3, 6. So these cells have to be 5, 7, 9. And therefore, these cells have to be 4, 6, or 8. And this one I know is not an 8. Fantastic. Okay. I probably also know what this digit is if I really squint. Because we have a 4 connecting to a 5 here, so this has to be the 6. So that's the 3. These are a 1, 2 pair. Looking that direction. Aha! This 4, 8 looks at this black dot. So remember, this string of 3 black dots always needs a 4 on it. That 4 can only go here. And now I can't use an 8 here. Because there's an 8 in the column. So I can't go 4, 8. I mean, there's lots of reasons I can't go 4, 8. I have to go 4, 2, 1. Like that. And so we get more goodies to start with. Okay, there is a 4 up here somewhere, I am noticing. I'm just scanning to see if there's any Sudoku stuff that I'm capable of noticing. I don't see it yet. Good point. Yeah, Kuraban, no bet sell until we finish the intro to Kropki, which will be after this. But I'm trying to make the sort of like the intro to Kropki bit snippable so that someone can come back and watch it later. And so I'm trying to make it as condensed and information dense as possible. So yeah, this 2-4, looking at this, is also huge. Again, sort of, I keep saying this. Everything comes down to this picture, which of course, like you will visualize this picture very quickly. But the lack of ability to put a 2 or a 4 here actually rules out 1 and 8 as well. So this has to be a 3 or a 6. Sorry, this has to be a 3 and a 6. To be more clear. So this digit's not a 6. This is a 4 or an 8. So that's pretty cool. So now this white dot suddenly is interesting. Because this white dot can't have a 1 on it. Even though there's no 1 marked in the row, this white dot can't have a 1 on it because then it would have a 2, and that's not going to work. It can't have a 2, it can't have a 3, it can't have a 4, it can't have a 5 on it either, because if it had a 5 on it, it would need a 4 or a 6, both of which are gone. Can't have a 6. So this digit's actually from 7, 8, 9, and needs to have an 8. Anytime you have a bunch of digits in any puzzle looking at a white dot, you should take a minute to think if that white dot is actually way more restricted than it looks. And so this is an instance where that's true. The other way you could think about this, by the way, is, again, this white dot needs to have an even digit on it, but 2, 4, and 6 are gone. So the even digit has to be an 8. Whichever way works for you is a good thing to do. Hey, David, thank you for the $8 donation for Tutorial Day. Thank you. I'm hoping people like this tradition. I'm hoping that this becomes something that is popular and helps get new people involved, as well as hopefully being interesting for the usuals. All right, so we've got that's from 1, 2, 4, 8. Let's see. Okay. This dot. This dot sees a 6, so it's not 3, 6. So it's from 1, 2, 4, 8. But it also sees a 4. So it also doesn't have 4 or 8 on it. And so this has to be a 1, 2. So that is neat. Hey, see you again in a bit, Tony. Alrighty, so here's another interesting observation. I have a 4, 6, 8 triple in column 3. I'm not sure if this is what Naverio wanted or not. But this digit sees 4, 6, 8 in the column, and it sees 2 in the box. So this sees every even digit. So this digit is odd. If this digit is odd, what is it? Well, it's not a 1. It's not a 5, 7, or 9. So in fact, actually, this is a very weird naked single. This is a 3, meaning that's a 6. So that's a 3, and that's a 6. That's a 4, and that's a 5. Just because of that observation. And so now that's an 8. That's not a 5, of course. That's not a 5. In fact, this is a 6. 6 only goes next to 7. 7 comes down here and puts a 9 here. So we get lots of very cool stuff. So this dot now needs to have a 2 on it. So this is from 1 to 4, and it always has a 2. Because it doesn't have an 8 or a 3, 6. This cell, by the way, is not 4. This cell also isn't a 1, by the way, because if this cell was a 1, that would force that cell to be a 2 and that cell to be a 2. So this cell has to be a 2, actually. So now this digit's forced to be a 3, because it can't be a 1. This digit is a 1 or a 4. I don't know which yet. This digit's not a whole lot of things. So first of all, there's a 6 in this box. So this is not a 3, 6. It's a 1, 2, 4, 8 flavor. But this cell, which is from 1, 2, 4, 8, is not 2, 4, or 8. So it's a 1. And as soon as that's a 1, that makes that a 2, which makes that a 1 and that a 2. That 1 comes down here and makes that a 4. So now this, again, this is not 3, 6, because there's a 6 in the box, and it's not 1, 2. So this has to be 4, 8 in some order. And I know the order, actually. So that's an 8 and a 4. And so I get lots of cool stuff. That's not a 4 now. That not being a 4 actually forces a 4 onto this dot, which means that this dot is from 2, 4, 8. That one's not a 2. We don't immediately, I think, get that. Let's fill in the cells that won't matter, just based on current experience. 3, 4, 5, 6, 7, 8, 9. Okay, so this is not a 3 for the record. It's a 5 or a 9. These digits are 7, 8, 9. That one's not 8. It is 7 or 9. In fact, I know, and yeah, everything that's left down here, no, it's not a 5, 7, or 9. It is a, let's see, what's left in this box? We need a 1. We've got a 2, 3, 4. We need a 5. We've got a 6. We need a 7. Okay. 5, 7. Yeah, maybe I don't know anything about that. Which is very sad. Okay, let's look at digits. Looking at digits is often a good idea if we've got a lot of anything. So we've got some 4s, putting 4 over in one of these cells. Let's see, we've got, oh! I actually pencil marked it in a way that would have let me see it, and then I still didn't see it. This 8 looked left, so that's an 8. So now these 3 cells are known. These 3 cells are from 1 to, we've got 3, 4, 5, 6, and then we've got 7, 8, 9. So these are from 1 to 6. And that's great because of this white dot. So this can't be a 1, because then that would put a 2 there. It can't be a 2. So this is 2 or a 6. If this is a 2, then this is a 3. If this is a 6, then this is a 7. I can go ahead and fill in. Let's see. This is not a 1. That's not a 1. I am being told correctly. So that's a 1, which is cool. Okay, so now where does 1 go in box 9? 1 doesn't go on this white dot, so the 1 goes there. So that's not a 1. So now that's a 1. Continuing up here. So one of these two is a 1. I would love to say that this can't be a 1, but I actually don't see a reason why it can't be, right off the top of my head at least. Let's see, what about 1 in this box? Yes, 1 in this box. This is a good trick to come up to. 1 in this box is in one of these cells. But I actually can't put 1 on this dot, because if I put 1 on this dot, I have to put 2 on it, which at first looks okay, until you squint and realize that that would put a 1, 2 triple in the column. And I can't make 3 different cells from 1 and 2. So actually, 1 is ruled off of this white dot as soon as this cell is pencil marked 1, 2. So no 1 there, no 1 there, no 1 there, no 1 on there. This is the 1. So that's the 1, and that's a 2. So that was cool. If I look at where 2 is going to go in this box, I know where 2 is going in one of those. Just never mind. Don't listen to me. This cell's not a 2 now because there's a 2 looking at it. So this is a 4, 8. So where is 2? Where is 2 in this box? 2 in this box is on this dot, right? Actually, sorry, 2 in this box is just placed. 2 on this box is here. It has no choices. So this is a 3. That's a 1 and a 2. 1, 2, 3, 4. Okay. 9 in this box I know is here in one of these 2 cells. I know 9 is in one of these 2 cells because there's an 8 already pencil marked over here, so I can't put a 9 on here because it would be stranded. I can't put it with an 8. I can't put a second 8 in the box. The reason why I marked that is because these 9s look at this cell, making that cell a 7 and that cell a 9. That 9 now looks over there, makes that a 7, makes that a 5 and a 7. That 7 now looks up and makes that a 9 and a 5. So these aren't 5. That 3 looks left, makes that a 9 and a 3. So now, so these digits can only come from 5, 6, 7. Because again, 2, 4, and 8 are going in the box, so I need an even digit. So there's a 6 on this dot somewhere. That is 3 in the corner. Yeah, this is a delightful puzzle. This is exactly what I'm looking for when I say I'm looking for 2-ish star puzzles that sort of highlight a mechanic while being sort of like more advanced than a gas puzzle, but not so advanced as to become inscrutable. This column I can fill in. It's got 1, 2, 3, 4. I need a 5, 6. Oh, well, never mind. Let's just do it that way. Where is 6 in this column? Well, I've got a 6 up here already. So I can't put 6 in either of these 2 cells. So the only place in the column that 6 goes is there, which immediately makes that a 7. This can't be a 9, so that is. Box needs a 5, so that's it. This is a 4 or 8. We have verified what the rules say, that not all dots are shown. So we've got 3 digits here. We need a 3, 4, 5, need a 6, and a 7, and I've got an 8 or a 9. I don't actually know what mechanic is next week yet. It may depend on what I find for this puzzle, for the medium puzzle afterwards. Let's see. This can't be a 3 because this cell can't be a 2 or a 4. Let's see. If this were a 6, this would be a 7. If this were a 7, this would be an 8. So there's always a 7 on here, but I don't really feel like chasing that yet. Let's fill in these 3 digits, and these 2 digits, maybe more importantly. 1, 2, 3, 4, 5. We need a 6 and an 8, and we know the order. That's the 6, that's the 8. What about these 3 digits? These 3 digits are 3, 4, 5, 6, 7, 8, 9. Yeah, so the usual 5, 7, 9 are the cursed digits that show up in these puzzles. Okay. I am noticing now, though, that this 7 actually resolved this bit, and I didn't notice. So this is now an 8-9 pair that's looking at this digit. So this digit's a 5. So this digit's not a 5. So we've got all of that going on. This 9 looks right, so that's a 7 and a 9. Let's fill in these, because these seem very likely to be useful. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I need to find 2 digits out of 4, 5, and 9 that are consecutive. And so hopefully it then makes sense that I cannot possibly put a 9 on this dot. So that's where the 9 goes in the row, making that an 8 and that a 9. So these have got to be from 3, 7, 8. Yes, where does 8 go in this box now? That 8 looks up and rules 8 out of everywhere except here. So that's an 8 and a 7. These aren't 7. They are a 3, 6 pair. Even more not given dots. This is a 3 or a 7 to finish the box. That 8 looks up and makes that a 4, an 8, and a 4. That 4 looks down and makes that a 5 and a 4. Let's go ahead and fill in these rows, because now I'm particularly interested in column 7. 2, 3, 4. Yeah, then we've got 5, 6, 7, 8, 9. This is from 2, 3, 4. It's not 4. That one's not 4 either, so that is 4. These are, let's see, we've got 1, 2, 3, 4, 5, 6, 7, and 8, 9. So this one's not a 7. This is a 5 or a 6. Yeah, this is the one that I knew had a 7 on it, so that didn't help. What about these? 1, 2, 3, 4, 5, 6, 7, 8, 9. That one's not an 8, and that one's not an 8, so that one is an 8. That one is not a 9, so it's a 5 and a 9. The 5 looks down and says that's not a 5. I must be misscanning something in this column. I am misscanning something in this column. That 5 looks there and sees that that's a 6 and a 2 and a 6 and a 7 and a 3 and a 6 and a 3. 6 looks down and sees that that's a 7, so that's a 5. That 3 looks down and says that's a 2, and that's a 3. Great puzzle. So if you're interested in making a like Zeta tutorial series puzzle that highlights one mechanic, you should look at this kuraban puzzle and just try and make something that is this awesome. Now, kuraban, I admit, has a huge head start on everyone else because kuraban has a series of 15 puzzles that highlight exactly one mechanic that are almost all in the 2 to 3 star difficulty. So I will be... I may be choosing kuraban puzzles for a while, although I saw that kuraban I don't think has a renban puzzle yet in that series. So if you want to make a 16th, it's a renban puzzle, that would be delightful. All right. So that is my intro to Kropki. So I hope you learned something and enjoyed that. I enjoyed the quick puzzles. They're fun to do. I know maybe not quite as interactive for the stream, but I'm hoping that this will really help get some people who are interested in getting into variant Sudoku, help them sort of like get their feet wet, get into the stream a bit, and start to follow some of these things. And I know it's a bit hard to do that when most of the puzzles that we do are sort of a mix of a whole bunch of different things, which I really enjoy those. And yeah, David is right that Cracking the Cryptic just came out with an app that has Kropki and XV. So if you want a whole bunch more Kropki XV puzzles, there you go. You can get the Cracking the Cryptic app. I will say again, I say this all the time, I really wish I could stream the Cracking the Cryptic apps because I think that would be good for everyone involved. But Cracking the Cryptic has chosen that they prefer people not stream their apps, so I won't. But I think the Cracking the Cryptic apps are very good. I can say that, and I promise I'm not sponsored to say that. I think they're good and fun, and so I think if you're trying to get into something, I think they're a good way to sort of get into a new constraint. All right, I'm going to take a real short break, and I'll be right back with, and I've already sort of revealed this. This is the puzzle we're going to be doing when we get back. So if you want to be looking, there are some Renbon, but there's also some fun ambiguity stuff. So we'll get to it very shortly. Be right back.